Michael, good luck. Biology and medical videos. Join the group. Post interested things, comments, ask questions, and answer questions. And you can subscribe the group to get medical information. In this group, we are going to look at glycolysis. In this topic, rather, we're going to look at glycolysis. Glycolysis, we can split into two words. That is glycol and lysis. Glycol means glucose. Then lysis means breaking down. Now, if you join the two words, glycolysis therefore becomes the breaking down of glucose. As simple as that. Now, the primary process, the primary source of this process is glucose. And in the other previous video, we say that process of glycolysis occurs in cell. Now, today we want us to look at the anatomy and physiology of this process. When I talk about anatomy, in biology, I mean the structure. And when I talk about the physiology, I mean the processes. So we are going to look at some few structures and the processes that occur during this process. And what we want to begin first is to see how the cell obtain glucose, or how glucose moves to the cell. I'm beginning from, you eat carbohydrates, then it moves to your stomach, I'm calling this to be my large intestine, and then around the large intestines we have small intestines there. Then around somewhere here I have my pancreas. Then around here I have my liver. You can improve the quality settings of the diagram. Now, you're going to eat your carbohydrates, pass through the digestion processes, and then reach to your stomach and then to your small intestine. Now, in the small intestine, I am going to zoom out my small intestine. That is my small intestine. Now, in the small intestine, I have something of this kind. So this is my small intestine, the luminal. Then here there are some space, and then attached here we have the blood vessels. Now, in this small intestine, there are holes, the membranes. We have membranes around here where the glucose passes through, and these membranes inside the small lumen of small intestine is known as apical membrane. Apical membrane. Then also the other side of the tissues, of the blood tissues, we also have membranes. The membrane is known as the basolateral membranes. Basolateral membranes. Now, this is your glucose. The glucose is going to cross these two membranes to reach into the blood by a process known as sodium co-transporter. That is sodium glucose link transporter 1. You can call it sodium glucose lift transporter, or you can call it sodium glucose link transporter. Now, when the glucose reach the bloodstream, it will therefore move to the liver. The glucose will move to the kidney. Let's take this to be our kidney. Now, inside the kidney, it will be filtered. The filtration will take place. And once it's filtered, it will be again reabsorbed back to the bloodstream. Let us also call this to be our bloodstream. So here, filtration will take place. This is kidney. And then this is bloodstream. Now in the bloodstream, the glucose will be filtered and then absorbed back to the blood. In the kidney, the glucose will be filtered and then reabsorbed back to the kidney. And then once it's reabsorbed back to the kidney, it will also still follow the membranes. It will follow the membranes around the tubulars, glomerulus tubules. Then also enter through the membranes of basolateral membranes in the bloodstream. So this, therefore, we will also use the same as sodium glucose link transporter 2. And here is when remove again to all the tissues of the body. Once it's already filtered and reabsorbed in the bloodstream, from here, therefore, it will move to all tissues of the entire body by what we call glucose transporter. It's what we call glucose transporter. A glucose transporter has got 3 classes. And in this case, we are going to look at only the first class, and that is glucose transporter 1, glucose transporter 2, glucose transporter 3, and glucose transporter 4. This is the first class of the glucose transporter. Now, glucose transporter 1 transport from the kidney to the bloodstream. That's the red blood cell. And then it also transport to the filters. And then it also transport to the blood-brain barrier. Then glucose transporter 2 transport to kidneys, transport to small intestine, transport to the liver, and transport to the pancreas. Glucose transporter 3, transport to the placenta, transport to the neurons, transport to the kidney. And then glucose transporter 4, transport to the muscles, transport to adipose tissues, and then transport to the heart. Now, if all this might confuse you, you can use a mnemonic known as big fat boys. Big fat boys are in the glucose transporter 1. Big fat boys kills shall left produce nervous kids with mad father at home. Now, produce is placenta, nervous is neurons, kids are kidney with mad muscles, fathers, fats, then home is heart. So this is the class 1 of the glucose transporter. Now, in the next video, we shall look at how now from the bloodstream this moves to the liver. We shall start from here, how the blood moves from the liver and then to the extracellular tissues and then to the cells. From the liver, moving to the extracellular fluids, and then to the cell, and then from here we shall now be looking at the process that will occur. That is the process of glycolysis, or the physiology of glycolysis inside the cell. I hope this will make sense. But of course, also the important information that I want to bring here is that diabetic patient, the diabetic patient can be given also what they call sodium co-transporter inhibitors, or sodium glucose lift transporter inhibitor 1. That means the inhibitor will stop or reduce the level of glucose that will be entering into the bloodstream from the small intestine. Then at the same time, they can also be provided with sodium glucose transporter inhibitor 2. This will reduce the amount of glucose that will enter into the kidney, and at the same time will also reduce the amount of the glucose that will be reabsorbed back to the bloodstream through the glomerulus, renal glomerulus tubules. So this is where we can stop from for today. In the next video, we shall look at the physiology of the glycolysis inside the cell. Bye-bye.